Hi, this is Future Who's Before we get started, I want to do a little apology here. The first approximately 10 minutes of this are going to have very choppy video. When I originally streamed this, due to my setup, I was dropping a whole lot of frames. You'll hear me refer to lag in the recording. Unfortunately, I didn't realize that this was causing me to lose frames from the output. But on the bright side, the key information is still there, and I get it fixed pretty quickly before we start any real work. So, that said, I hope you'll enjoy the video and forgive my mistakes. Okay, we're going to be taking a stab at this. We're going to be making a game in 90 minutes as a preparation for a workshop I'm going to be co-hosting. So let's go ahead and get started. Hopefully this time, as opposed to earlier today, we've ironed out some of the bugs. So let's hop on over to Unity. Alright, so we've just got a an almost empty scene set up here. We're in Unity 2018.3.0 F2, which was just released today. I believe today. And we are going to be making a random game. So the only things I've added to this scene, other than just starting it up, are this prefab, which I'm going to bring in now to choose our random game. It's very simple. It's got a script on it with a list of games we're going to pull from. That script is here. Choose random game, which should pop up this. All we do is grab a random game from the list, output it, and set our text mesh. Yeah, to that. Well, okay, something interesting happened there. Don't worry about it. Alright, so we've brought that in. We're just going to hit play and let it choose a game for us. Let's see what we get. It's taking a while. Interesting. There we go. Lander. Okay. So, we're going to be making Lander. Let's stop. Getting some weird lag. Alright, let's get rid of choose random game. Let's go ahead and create ourselves a few folders here. One for materials. What else are we going to need? We've already got prefabs and scripts. So we'll leave it alone for now. I'm just going to pop another folder in here called meta. Drop that in there. Same over here. Actually, let's call it. Let's make a folder this. Whoops. Choose random game. Like so. Let's pop that in there. And let's pop that in there. Okay, and we can pop this up here. Let's actually just call this meta. Alright. Cool, so we're going to be making a lander. Now, I have played Lander very seldom, so what's happening? It's complaining about Visual Studio. Reload. Okay. Alright. Interesting. Some weird stuff going on with rebuilding the solution, but Okay, so we probably shouldn't be dragging around scripts while we do this. Let's go ahead and set the game that we're making in our stream view. What is going on? Okay, let's do Lander. Cool. Can we... You know what, let's just close Visual Studio and... Oh boy. Let's create a script for our player. And hopefully get this weirdness cleared up, maybe. I'm just going to blink the screen real quick as I attempt to reopen the solution. Opening Visual Studio. None of this is counting towards our time yet. So there's always hiccups. I guess we learned that we shouldn't move scripts and folders around too much with this open. Let's open the project or solution. Preparing solution. Okay. Okay. All right. There we go. Display turn on. All right. So we have our player class. Cool. And any errors over here? No. All right. So let's set our deadline. So our deadline is going to be 90 minutes from 7 p.m. Let's label that. So that would be 8:30, right? 8:30. All right. Good. Okay. Well, let's give ourselves 1 extra minute and get started. Let's see. Oh, shoot. Just going to turn off the display. 1 second. Okay, we're not getting started yet. What we are doing is actually opening up the browser without any weird stuff showing on the desktop. Okay, so we're going to be looking at Lunar Lander, which was an Atari game. Images. Okay. So we're going to need let's show our display again. There we go. Alright, so we're going to need some things. First off, let's rename the scene. Not from there, apparently. Right here. Let's just call this our main scene. And if I can actually type, there we go. And save it. Alright, so let's make a player. This is going to be our lander. I'm going to be working in 3D because I'm more comfortable in 3D. And we'll just make it 2.5D and we'll fudge it. It'll be great. So we're going to add a cube here to our lander. Yeah, we'll just call it player. So let's. Whoa. Man, I'm getting some serious frame lag. Alright. That was not the issue this morning. Let's add some legs to our little lander here. Let's go like 0.1, 0.1, and move you down, and move you out to here. Cool. Maybe like 25. Hi, this is me from the future. It took about 5 minutes to take the stream down and then bring it back up again using my actual graphics card instead of the built-in. The built-in was necessary to output the desktop display directly, and instead I had to go to window capture after this. But there shouldn't be any more dropped frames. So, I apologize for the cut. Okay, we are back, and hopefully without the lag. Here's where we left off. Let's try moving a thing around. That's reasonable. Alright. Back where we left. Okay. So, we're going to scoot our deadline forward a little bit just because of that issue. Let's give ourselves 5 minutes. Okay. Now, unfortunately, because of this, I will have to be switching back and forth between windows manually. And yeah, that's not great. But I'm running on a laptop and I can't output the display correctly without having major lag, it seems. So we're just going to do window outputs. Yep. And hopefully we'll come up with another solution later. Alright, but let's continue. So, lander. So we're going to need our lander, which will be here. There we go. We're going to go ahead and switch over to an orthographic camera, I think. Projection orthographic. Cool. And we can probably leave it mostly where it is, although let's increase the size a bit, maybe about 16. Okay, sweet. 16. Let's go ahead and change our background to a solid color, which will be black, because we're in space. Sweet. There we go. Space. We can keep the directional light. That's probably fine. So now let's monkey with this lander a bit. Let's move those there. This is going to be super weird, but interesting because it's shadowed. Let's just duplicate these and scoot them back there and there. We can play with perspective versus orthographic and see what makes sense. Let's run with perspective, actually. Maybe from about back there. Let's go -30 there. Okay, there's our lander. Yay! So, how does lander work? I don't really know. Let's look at Wikipedia. Lunar Lander. Player controls a module, attempts to safely land on the moon. Fires a thruster. Earn points, skillfulness and difficulty landing. Okay, so lander is going to fly in from the top, and we're going to use a thruster to control its velocity. Fortunately, it's going to be super easy in Unity, so we may have some time to polish this. And we're going to try and land on a certain landing point, and not crash into mountains. So let's make some mountains. I'm going to call this terrain, or yeah, ground or something. Ground. Let's call it ground. Reset, transform, and let's see. Okay, let's see. So we've got some ground here. Might be some noise in the background, but that will be fine. Let's go ahead and make let's just make some cubes for now. And we will get fancier later after we have our basic gameplay in. So let's make a big cube, drop it down. Maybe a bit smaller. Yeah, that's fine. Okay, cool. So there. Get some more, and just play around. Oops, these are moving these in the wrong orientation. Let's go around here. Yeah, you can go over here. That's fine. And we'll put you over here. Whoops. Actually, grab the correct handle. And we'll put you over here. And let's just duplicate these guys a little bit more. And get one over here. And you, that one, duplicate, go over here. Okay, so we have a very, very rough, just kind of ground. Alright. It's not actually final, it's, well, in any shape or form, we probably won't even be using cubes. But we'll leave that until later. This is going to be functional for gameplay's sake. So let's make the Lunar Lander do a thing. So we're going to use, oh hey, look at that, a rigid body. We're going to use Unity's built-in physics model, I think. Let's go ahead and give it continuous dynamic collision. Be the best. We are, let's not have any drag. We'll use gravity, yes. Angular drag is fine. So we can completely have an escape velocity or something, but should be okay. We're also not going to allow any positional change in Z, so we won't go forward or back into the depth of the scene. We also are only going to want to rotate in the actual Z axis, so we'll freeze the X and Y. And now that we've set that up, let's give it a run. And there we go, it falls, and if I pick it up, it falls again. Let's try and rotate it. There we go. And if we move it, yeah, nice. Alright, let's get some materials so we can actually see the difference in our items. So let's create a material. We'll call this Lander body, and we will open our player here. Let's put it on there, and let's duplicate this to make Lander legs. And we will put this on these 4 cubes into the materials. There we go. And on the ground. Oh wait, I need to duplicate this. Let's call this ground. Let's apply this material to there. Okay, and let's make some changes. So the Lander body, what should that be? Let's make that like a silvery gray. Over there. Sure. Let's make it metallic. Actually, no. Let's make it a gold, like the Lunar Lander. Yeah, the actual Apollo missions. And let's give it a 0.75 smoothness. Sweet. Cool. That's good. Let's make the legs something of a gray, maybe a little darker. About there. Well, actually, something about there so they will contrast well with what we're about to do, which is the ground, which will have a sort of moon-like gray. That will work well. Yeah, we don't have a lot of contrast. Let's take the smoothness of the ground down to, I don't know, 0.25. We could actually use realistic values for that, but never mind. Let's do the legs in, what is a color? Let's a good color to contrast things that also makes sense. Well, let's just make them mostly white. That should be fine. Alright. Save that. Cool. So we've got our player. They can fall. We've got some, different materials. Let's go ahead and make a landing pad. So let's create this here. An object, reset the transform. I'll probably put it down about there. Let's give it a cube. Let's duplicate that to make the landing pad. I believe, actually, let's just check the game. Do we have a landing pad? No, it has different locations that you land on for different points. Different amounts of points. But they're kind of pads. I guess they are different sizes, which give different amounts of points. Okay, so this will be fine. We're going to have a landing pad like this. Let's make it 0.2, maybe 0.5, maybe 0.25. Yeah, let's go with that. And let's put it about there, and we can change these later. 0.75, yeah, 0.5. That's halfway into the thing. You know what? It's fine. We'll leave it alone like that. Let's apply our landing pad material there, and let's customize that, and let's make it some sort of green. Yeah. Yeah, let's go with that. Oh, another thing that's important. Let's check out our project settings. Project settings. Okay, so under graphics, we're looking for our color space, which the settings have kind of changed in 2018.3. I don't remember where things are. Is it in player? It might be in player. Other settings. Color space. Yeah, here we go. We want linear color space because that's going to look much better. Okay. Now that's done. Yeah, it didn't change much right now, but it is fun. Let's also give our landing pad material just a little bit of emission. We're going to select same color, and that's probably fine. Okay, cool. Let's increase the size of the pad to make it like 2. Looks good. Alright, let's get some actual gameplay in here. So the first thing we're going to want to do is let the player blast off. So we're going to add a script. I did create a player script, but it is just an empty script. Yeah, there we go. Alright, so we're going to require components type of, I think I need friends here, type of rigid body, because this component, this player, will need a rigid body. In start, we're going to set that rigid body, so let's create a variable rigid body RB. In start, we're going to say RB is get component rigid body. Alright. So we've got a rigid body, so we can use that to control the player. So we're going to have two means of input. We're going to have rotational input and thrust input. So let's use some built-ins for some of those. First things, we're going to do a float thrust. We're also going to do a float rotation. Let's call these thrust input and rotation input. On update, we're going to change our, let's do thrust first. Thrust input equals to inputs.get axis vertical, using Unity's built-in inputs axes. And we are going to ignore the negative values here because we only want to be able to thrust forward. So we're going to say mathf.clamp. Actually, we don't need to clamp. We're going to take the maximum value of 0 and our input. So this will always be between 0 and 1. Likewise, we're going to take our rotation input. We're going to assign that input.getAxis horizontal. and assign that there. And this one we want to be positive and negative, so be fine. And by default in Unity, these are mapped to vertical to W and S, up and down arrows, and horizontal to the left and right arrows, and A and D keys. And we can change those as well if we wanted to. Alright. So we're getting input, but we're not doing any movement. To do our movement, since we'll be using the physics system, we're going to do that within fixed update. I forgot to switch over to Visual Studio. So here we are. Alright, so we've got thrust input, rotation input, and fixed update. Alright. Let's get back on track. Fixed update. So we're going to use the input to control the rigid body physics. So we're going to want to add force to the rigid body. We're going to add force of thrust input, which is the amount, times our transform dot up, because we want to go upwards. And we're going to have to apply or do this with a certain force mode, and we're just going to do let's just do a velocity change, which will ignore the mass, and it will do an instant one frame force rather than applying a force that will last. But since we're doing this in fixed update, it will happen every physics tick, so it should have the effect we want. Alright, likewise for the rotation, we're going to add force, although this is going to be a torque. So we're going to add torque to our rigid body. It's going to be our rotation input times, wait, hold on. So, we have some options here. So we can apply vector 3, a series of floats. We're going to do, I think, a series of floats. So we want to rotate around the z-axis. So we're going to do 0f, 0f, and then rotation input for the z. And then again, we're going to have force mode dot velocity change to just go ahead and apply those. Alright, so heading back to Unity, we'll wait for that to compile, and then we'll hit play. Alright, we're in play mode. Almost, almost. There we go, we've fallen down, and we can not do anything because I didn't put the script on the player. So here's our player, let's add the player script. There we go. Play. So we're falling down, I'm pressing the up arrow, and we go launching off rather fast. Down arrow does nothing. Let's try row. Whoa, 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 whoa. Yeah, okay. This is kind of fun. Let's try and land on our... Okay, so one thing is the left and right keys are switched. So that is left, and this is right. Whoops. And that's pressing left arrow again, and right. Okay. If we take off, I just want to make sure that we're actually going to thrust in the right direction. It looks like it. Yeah. It looks like we're thrusting forward. But let's get a better handle on that. So, let's go back to Visual Studio, and let's get some parameters that we can adjust here. So we're going to serialize field, because it doesn't need to be public. We're going to do thrusts. Let's do thrusts like speed or power, or let's do sensitivity. Thrust, let's just do power. That's fine. Thrust power. Oh, and this should be a float. Whoops. And this will also be a float. And this is going to be torque. Power. Let's also actually name this, instead of rotation, let's name this torque. There we go. Torque input. Cool. All right. So we have these floats. Let's initialize them at 1. And let's go ahead and take these into account. So we're going to multiply thrust input by our thrust power, and then by transform.up. Likewise, we're going to multiply torque input by torque power. All right. Let's also put this sort of in seconds. Or meters per second, or units per second. So to do that, we're going to multiply also by time.delta time times all of these. Same down here. All right. Now, if we go back into Unity, we should already see a change once it compiles. Okay, we have thrust power 1 and torque power 1. We're multiplying by 1, but we are multiplying by time, so we'll see a significant change in responsiveness. Okay, I have next to no control. So, maybe let's not do times time. I'm just going to take that out. No need to switch over the stream. Maybe we can add that back in later. Compile. Let's go to save. All right. So we should see the same effect as before. Yep. Looks just as crazy. All right. So back in Visual Studio, I did forget about flipping the left and right. So let's go ahead and do that. All we're going to need to do is just set the input to negative the input axis. All right, cool. And that should be an improvement. Let's go ahead and try fiddling with our torque power and everything to be something reasonable. Let's try 0.1, and let's do 0.5 for the power, and then we'll play with those in the actual play mode. Okay, that's cool. That's not terrible. And turn right. There we go. Whoa. Ooh. Ah. Ooh. It can get out of hand real fast. And we're just stuck now. Okay. Well. Let's play with these a little bit more. So left. Okay, what I'd like to do is add some more angular drag. That way we aren't spinning endlessly, and it's more like the actual lander game, I think. Alright, so our rotation will gradually slow down, maybe even more. Let's do an angular drag 1. Now that's going to apply, or yeah, we're definitely stuck. It's going to change how much we can actually apply our rotation. Whoop, there we go. I don't know. It's weird. One thing we should do, though, probably is make some boundaries. Boundary? Yes. No, boundary. And let's go ahead and give this some cubes. We'll go ahead and give you 5, 5, and in Y we'll give you like 50. Sure, good enough. Move it up a little. This is just super quick. You know, not meant to be actually representative of final project or product. Interesting. Our view is slightly off-centered. Or our objects are slightly off-center. So, aha. You're at 19, you're at negative 20. Let's put you right there at 20, negative 20. Great, and we can kind of see that on the edge of the screen. That's fine. Let's not worry about it. Let's go ahead and put in a top boundary. Change that scale to 5. The X width to what? Like 20? No, 30. You know what? This doesn't matter, so let's do 50. Let's do overkill. Center there. Move it up to about the top of the screen. There. Alright. So those stick out, but it's fine. We're doing this super quick. Speaking of which, it is currently 7:40, and we have until 8:35, so that means we have an hour left. We spent 30 minutes. Okay. Well, technically 35. And a little under an hour left. What's next? What's next? What's next? Let's get that centered up just because. So what do we need to do? So the player needs to just lose if A, they land not on a landing pad, and B, they they impact at too high of a velocity. So let's track that over in our player script. Let's go back to Visual Studio. Whoa, what's going on there? Weirdness, that's what. Alright, okay. So let's make a function. We're going to use some of Unity's built-in collisions. So on collision, answer. Actually, is it on collider enter? On collide, we're going to need to look this up. I got it right. On collision, enter, and we're going to take a collision. Collision. All right. So, with this function, we have some information about the collision. And this will get called on the object with the rigid body if the method exists. So if onCollisionEnter exists in a script attached to an object with a rigid body, will get called when we hit something else. So let's do this. Let's say first of all, if we're going too fast, we're going to explode. So let's make a void explode. And what we're going to do in explode is just destroy our game object. Cool. And we will eventually make that reset our scene as well. But for now, if we collide with anything, we're just going to explode. Actually, that's a bad idea. Let's not do that. We should say, yeah, no, let's just see what happens. Let's save that. Let's go back to Unity. Okay. And see what happens. Alright. Falling. Whoa. Holy cow. And it worked. Huh. Okay. That's fine. I guess we don't have internal collisions. We're also going to put the lander at the top of the screen. Actually, maybe let's move this boundary cube up some and have the lander just nudge in off the top of the screen at the beginning. And scoot this down a little. There. Okay. Sweet. Alright. So let's change a few more things. If, back in Visual Studio, let's say if our velocity, so rb.velocity, the rigid body's velocity, dot magnitude is greater than, let's say our safe velocity, which we'll make that seems alright. Then we're going to explode. So let's make that safe velocity a parameter. And let's initialize it to 1. Cool. So we have our safe velocity. Back in Unity. I'll check our player over here. Safe velocity is 1. Let's put that up to something like 10. Alright, now we're coming slowly. Oh, and we exploded. Alright. What if we set it to 50? We exploded. What's going on? Oh, that's what's happening. Alright, let's go back. Let's not always automatically explode. Hey, we touched down. Yay. Let's change our safe velocity to 10. And see if we can still land. Okay, we can land pretty heavily. Let's do 5. Meow, bonk. Meow, bonk. Alright. Let's do 2. That's pretty heavy. What about 1? Alright, let's get real ridiculous. 0.5. Interesting. 0.1. Odd. 0.0001. Something's going wrong. Safe velocity 0. Interesting. Let's head back to Visual Studio and take a look. If our magnitude is greater than safe velocity, then we explode. And we do. It's just very, very low. Well, alright. What I can think of right now is adding some sort of visual indicator during play for when our velocity is unsafe. So let's do that. Back in Unity, we're going to add a yeah, let's just do this on the player for now. To keep things super simple, we're going to call this warning lights. Actually, no. Let's make an empty game object called warning light. If I am actually selecting the thing I want to type into, warning lights, there we go. Zoom in on that. Let's go up so it's at like 0.5. Cool. Let's make this, give this a sphere. And make the sphere like 0.5, 0.5, 0.5. Sweet. And we're going to duplicate that material to make a warning light material. Let's do warning light on. Oh, let's do warning light OK. And let's set the albedo to, let's make it green. Cool. Let's give it that emission. Alright. And we're going to apply it there. Sweet. Duplicate this to do warning light danger, and we're going to make this one red, and yeah, it's fine. That's fine. Okay, cool. So we're going to call this sphere OK, and we're going to duplicate it and call this sphere danger. We're going to do this a little, a little weird. So let's apply that material. Let's turn both of these off. Actually, we'll leave OK as on. That's fine. Okay. And let's actually add some lights to these. Let's add a point light for funsies. Color green. Duplicate this. Put it under danger. Color red. Great. Perfect. So now if we turn danger on, there we go. Cool. And it's appearing yellow because they're mixed, but we're only going to have one on. Sure. Let's go back into Visual Studio and control those a little bit. Alright, so we're going to need serialized fields, game object, warning light OK, and warning light danger, and we won't error check for these being null. We're just gonna deal with that. So during fixed update, or during updates, fixed update, let's do this. Let's make a boolean safe let's just set this as true. Let's call this safe to land. Maybe say is safe to land. Alright. So that's going to start off as true. So during fixed update, we're going to say if our magnitude is greater than our safe velocity, then we set is safe to land. Actually, we can just set this equal to that, or less than that. We could say less than or equal to, but it's fine. It's gonna be alright. So now is safe to land there, and in update we will set our warning lights. So warning lights OK dot set active. We probably shouldn't be setting it every frame, but we're not going to worry about it. If it's safe to land, we'll turn it on. Otherwise, we will turn the warning light on. Warning light, warning light, danger. Whoops. Okay, let's check that out. Back in Unity, let's check our player. So those are not set. That's fine, we will set them. So warning light okay, and warning light danger. Let's set our safe velocity to like 0.00001. That's cool. Let's go. So unsafe velocity. Okay. I'm going to pause, and let's change our safe velocity to 0.0001. And unpause. Okay, we're never safe. That's fine. What about this? Huh. Previously we were crashing with these. Interesting. Whoops. Safe velocity is 1. Oh. We're actually getting a slight change there. Sweet. Right. Let's set this back to Mach 3. Alright. Something is fishy. So I think perhaps the rigid body velocity's magnitude is getting set somewhere weird. So we're just going to check if it is safe to land. And if it's not safe to land, we explode. Alright, back in Unity. Let's try that out. Come on, play mode. Compile. Awesome. We're getting some stutters there, but I think it's fine. Ooh, we did that. And now let's go unsafe. Boom. Okay. So that will need some tweaking. We'll leave it. We'll put it at 5 for now, I think. Let's see what it does at 10. Unsafe, safe. How fast do we have to be going? And there. Okay, that seems good. Let's leave it at 10. All right. That's our player. Let's add some similar sort of logic to show when we are using our booster. So let's do this. We're going to say that this is the we'll say that's the lander, and we'll put the cubes in there just to be more organized. Okay. All right. And these warning lights have some collision, but that's all right. Actually, let's go ahead and move the lights of these up just a little bit. There we go. So that they shine off of the top. Let's go and put them at 1. Yeah. Okay, cool. Alright, let's make an object called thruster, and we're going to put it at the bottom of our lander here at -0.5. And hope that I can type properly. There we go. We're going to give it I don't know. We're making things out of cubes so far, so we're going to give it a cube. You know what? Now let's be fancy. First off, let's call this thruster effects. Let's make a a subobject called flare. We're going to make a sphere, actually, I think. Yeah, this should work all right. If I adjust the Y scale of the flare, it'll flare out like that. But we need to remove the sphere collider. Let's go ahead and make a material called thruster flare. Once again, template it thruster flare. And let's give this some sort of orange. Yeah, okay. HDR that. Alright. Cool. Let's apply the flare here. And let's size this using the E key. Let's get the scale tool. And so it looks like about 5.5 and 0.5. Cool. We're also going to move this to about there, I think. -0.2. Now, if I scale flare in Y, we get that sort of effect, which is great. Sweet. Alright. So there. Let's see. 8 o'clock. Well, 8:05. 30 minutes remain. Okay. Let's see. Let's give this flare some code. So let's go back to Visual Studio. We're going to need the flare's transform. So we're going to call this thruster flare. Let's initialize these to null, just so we'll stop getting warnings about that. There we go. Okay. So we can set this in update. So all we're going to do is say so thruster flare dot scale, local scale, equals to a new vector 3. Actually, we'll do this. Vector 3 thruster scale equals to. Seriously, I wish I could type thruster properly. Equals to the local scale. We're going to set the. Actually, can we set the value directly? Let's try setting the value directly. Local scale dot y equals to thrust input times a magic value like 5. What's it? That local scale cannot. Okay, it's not a variable. Right. Can we set? No. Can we set this? new x, new y, new z. Sure. Yeah. We'll set the x to 1, y to that, and the z to 1. Get rid of that. Alright. Let's check that out. Back over here in Unity. We're going to, okay, so the scales are all 1, yeah. We're going to say our thruster flare is this flare. Okay. And let's check it out. So now when I hold up, nothing happens. Correct. Oh, I know why. It's back in Visual Studio, because we're setting the vector that is returned from this, but that doesn't actually do anything. Okay. So we'll just directly set it to a vector. There we go. That should work. Okay. Hey, there we go. Look at that. Whoosh. That's pretty sweet. Whoosh. All right. What's next? It looks a little bit ugly when the scale is 0, so let's fix that. We'll say if our thrust input is greater than 0, then we do this. Oops. Else we set thruster flare dot game object dot set active false. Over here we want to set it to true. Okay, cool. Make sure that works. Yeah, it looks like it does. Sweet. Excellent. Boom. Okay. So, so far all of the code is in the player. To save time, because we only have like 20 minutes left, we're just going to keep it that way. But let's make the scene reset if we crash. So back in Visual Studio. Let's see. To reset the scene, we're going to need you to use Unity Engine.scene management and in explode. We can destroy it, but we can also reset the scene. yeah, let's just do it right away. So we're going to want to say scene manager dot load scene, and the scene that we're going to load, we have to get the build index of it, and it's just going to be this scene. It's the current scene. So we're going to say scene manager dot get active scene dot build index. Parens dot build index. There we go. So this will reload the active scene, and we can test that. And see if we crash. Boom. And we reload the scene. There we go. Alright. Sweet. So, we need to know if we landed safely on the landing pad. So, back in Visual Studio. Well, no, not quite yet. We're just going to make a little script here called landing pad because it'll come in handy later. We're going to apply this. Once it compiles, we'll apply the script to our landing pad. Okay. And then take a look at our player. So, player, on collision, enter. So, if it's safe to land, if it's not safe to land, we explode, and we're going to return after that. Even though we'll be reloading the scene, it's fine. So, if it is safe to land, it is safe to land. Check if we're on a pad. So, let's see. If collision dot transform collision dot get I think collision dot transform dot get component. Whoops. Come on, get component in parent, and we want to get landing pad. So if the parent has a landing pad component, actually, let's say this. So landing pad pad is equal to this value, and then if our pad is null, then we've landed safely. Landed safely. Whoops. On a pad. And we're going to do this. We're going to say reset scene. Stick this in a little function of its own. Why do I do double enter every time? We're going to reset scene there. If we explode, we're going to debug.log exploded exclamation mark. Whoops. What did I do there? I'm going to copy that. We're going to say void land and actually let's move this down there. So landed. And in both cases, we're going to want to reset the scene. but oops, not there. Ah. Copying and pasting the wrong thing because I'm going too fast. Okay. So, if we have landed, we should say landed and reset the scene. So, if we're safely on the landing pad, then we will call land. Back in Unity, we'll take a look at our landing pad. Okay. It has a landing pad script. So now, if we hit play, we should be able to explode. Boom, exploded. Scene resets. If we safely land, hey, we landed a lot of times. Interesting. Okay. Oh. Right. I know why. We get that error or that message several times because we actually have 4 colliders that are landing. Each of our little cubes here is triggering that on collision. So there's a number of ways we can handle that. What I think I would like to do is just, if we've landed already, ignore the rest of those. So let's make a boolean has landed. Has landed is true. Actually, this should start as false. Let's also make boolean called live, which will start as true. So on collision enter, if alive is true, so we only care about our collisions if we're alive. There we go. And if landed has landed, and my variable naming is a little bit inconsistent, but that's alright. If we have landed, if have landed is false, then we can land. If we, so in land, we're going to say landed, and we're going to set has landed to true. Where in explode, we're going to set alive to false. Alright. And we can also say only change things in update if alive is true. Cool. I think I'd also like to do something else here. Rather than destroying the game object immediately and resetting the scene immediately, let's get a little timeout. So we're going to change this to IEnumerator, reset scene. We're going to make it a coroutine. We're going to take in a float delay, and we're going to yield return new wait 4 seconds. Whoops. wait 4 seconds, delay. So we're going to only come back to this coroutine when delay seconds have passed. Now we can say instead start coroutine, reset scene, and we'll give it a delay. Let's just use a magic number. Let's say after 2 seconds. Okay. And let's hope I type things correctly. Okay, so now the game should only reset after 2 seconds. We are going to destroy our game object there. Yeah. Okay. Going back to Unity. Let's give this a save. Alright, there we are. We're coming in. I'm going to try for a good landing. Hey, we did good. There we go. And if we come in for a bad landing, boom, we exploded. And we reset. We reset. Oh, because we're destroying our game object, we're not able to reset. Aha. Because the coroutine doesn't trigger because game object is gone. So let's not destroy it. That'll be fine. One thing I did notice, we don't want to control we don't want to be able to control our lander after we have landed. Let's actually rename has landed to just landed. All right. Let's go ahead and rename safe to land as, or is safe to land as safe to land. A little bit more consistent. Okay. So let's just make sure that works. Back in Unity. Clear our console and start up. Okay. And land safely, and well, we have landed, but we can take off. Why? We said, ooh, landed is true here. Oh, heck. Because we have the code in the wrong function. Alright. Let's try again. Whoops. Okay, that's fun. So we also need to on land set landed is true. Let's go ahead and do these things in that in fixed update, and we'll manage those things. Let's say else here. Well, no, we'll set these ones. We'll set in landed or land, so landed to true. Set the game object as inactive, And we don't need to worry about the local scale. Sure. Alright, now we shouldn't take off randomly when we land. Cool. And we can't move. Okay, good, perfect. Wow. Sweet. And we can still fall over. But that's fine. That's value tweaking. 828. Alright. Let's do the actual point of this, which is scoring. Let's also, yeah, okay. So what we're going to do is in landing pad, we're going to make serialized field int value. Let's say points. Sure. Let's make it, yeah, let's make it int. And we'll give it 100 points. So actually, instead of serializing that, we're going to make that public. Public int points. Save. Back to player. So let's make a function called get calls. You know what? We don't need a function for this. Let's store a value, a points value. So that should be an integer, should be public or private. Let's make it private. Points starts with 0. And let's make a function. Void modify points. And we're passing value. So we're going to say our points equals to our point, or yeah, points plus our value, except that we're going to stop at 0. So we're going to say f.maximum between 0 and our modify points. There we go. And when we land, we want to modify points. And we want to give ourselves the amount of points of the pad we landed on. So we're going to take in a landing pad to this function. We're going to land on that pad there. So modify points, we're going to pass in pad.points. Cool. If we explode, we should say, I know we're resetting the scene, but I'm not going to worry about that right now. Let's say modify points. Let's just say -100. Okay. I would also like to do can we do this? We make points static. this might work. Let's go back to Unity. This is not a good way to do things, but it is a timely way to do things. We also won't be able to see our points value. So actually, let's go in Visual Studio. Say on start, we'll just debug.log it. Points, yeah, points, and output points there. All right, back to Unity. Let that compile. 2 minutes left. All right, so we have 0 points, and if we land, we landed. Now we're gonna reset. Now we have 100 points. Let's crash. Well, no, let's land safely first to get 200. Cool, landed. And let's crash. Boom, exploded. And our points are back down to 100. Sweet. So, as the very last thing we're going to do, we're going to make those points visible to player instead of just in debug. So we're going to add a UI text element, and we are going to center on that. This color will be an off-white. There we go. Let's make it bold. Font scale like 64. Let's increase the size. Okay, center. Put it at the top of the screen. Looks good. Font size is fine. Actually, let's make it 32. All right. Focus on it. F. Keep that there. And we're gonna say points 0. Okay. Cool. We've got that. So now in our player script, we can say we're going to need to use UnityEngine.UI to access the user interface classes. We're going to have a yeah, sure, let's put it down there after all. Let's get an object of type text, points text, initialize to null is fine. Then when we modify points, we're going to say points text dot text, whoops, dot text equals to, let's actually make this a string, points string equals, wait, what? Oh, right, oh well, we'll just do this, points that plus our actual points value. I'm a little bit confused there. So, that should be our modified points updating. We can keep the debug log in. Let's go back to Unity and see if this will work. So we have our player. We're going to need to assign the points text there and see if we can run it. Point 0, land safely, landed. We are at 100. Ah, we didn't. So we didn't update our points text. when we reset, we should, let's just call modify points 0. So we won't change it by anything. And we'll put the debug log in here. Cool. Wait, no, in here. Save. Go back. Oops, I didn't show Visual Studio that time, but there we are. Alright. And land safely. Points 100. Wait for it to reset. There we go. We still have 100 points. If we land again, we have 200 points. If we crash, boom, we have 100 points. Excellent. So, we are past time, but I just want to demonstrate one more thing, and that is if we, let's make a prefab out of our landing pad so that we can place it other places in our scene and set individual values for them, but still have the main template the same. So let's make another landing pad. And let's put this one, oops. Let's put this one there, and landing pad 2, let's put you over here, and let's give this one points 1000, and this one points 500. So now, we should be able to, maybe, if we can actually pull it off, safely land. There, 500 points. Excellent. And here, another 100 points. And if we crash, boom. All right. So there we are. That is the basics of Lander in approximately 90 minutes. There's a lot of things we could do to this to clean up the code and make it better. I was planning to do some actual terrain and maybe do an explosion when our lander, when our lander crashes, do a visual explosion. But the rest of this is honestly just polish. We have the mechanics in place. We could tweak the way the lander crashes, the way it explodes. We could have it automatically crash if it's on its side, for instance. Make that not safe to land. We could have it do all sorts of things. Lots of visual effects to add, sound effects. We should really actually have a menu and such. But really this was meant to be focused on the mechanics and just what you can do in a very short time, and how you can just hammer things out as quickly as possible for a GM format. And I think we've achieved that to some extent. I'm going to make this project available. When this goes up on YouTube, I will put the link to the project in the description. And maybe work on it some more, just add some of those visual effects, some of that polish, and make that in a separate project as well. Thanks for watching, and I hope you got something out of it. we may or may not do more streams like this one in the future. But that's it for Lander. So thanks and goodbye.